Are you ready for the best day of pre-calc? Yeah! This is going to be a very challenging section, but we're here together. We're one big team, so we're going to do it together. I'm going to go through these notes and then we'll practice in class. So, a little background, you will always be given this geometry formula sheet. You'll be given it on all standardized tests, which means we'll give it to you on any pre-calc assessments we give. Okay, so it's a little reminder about geometry. You might have taken it last year or the year before. There's just a couple formulas you want to be familiar with. We have them all broken down by shape and we'll use them as we move forward. Here is also some more problems. I kind of got cut to the next page, sorry about that. But here are some more symbols, maybe that you need to review. But again, this will be given to you. Okay, all of these problems need to be thought of as a puzzle. You know so much knowledge, but now we need to hone in and answer each problem as it's asked, okay? So, my big thing when I tackle these is draw pictures, as you know, pretty visual person. So example 1 says the perimeter of a rectangle is 50 feet. Here I go, draw my rectangle. I know that the perimeter equals 50 feet. I now want to find the area as a function of the length of the side. Okay, so what I want to find, I'm going to put it down here, what I want to find is area of this rectangle, which area is length times width. But I need it as a function of length, which means W needs to be replaced with something else. Okay, so this is my goal right here. I'm going to use what I know about rectangles in the perimeter to replace W to get a function of length. Okay, so it's important to understand what we're doing. Well, looking at this, here's my length and my width. If I know the perimeter is 50, I actually know that 2L plus 2W will equal that perimeter for me. Well, this is starting to look good. If I can get W by itself and substitute it in to my highlighted function, then I'm almost done. So let's try to do that. Let's get W by itself. I can get 2W equals 50 minus 2L. So W is 25 minus L. If I take that, plug it into here, I then will have area just with the variable L. So here we go. I'm going to make sure I put my parentheses because that would be silly if I didn't. I know I'm going to have to distribute this now. So my area is actually 25L minus L squared. That answers the problem of area in terms of length. Okay, next one. Example 2, a rectangle is inscribed in a circle. First thing I'm going to do, draw my circle. Inscribed means inside. As good as it's, oops, that's not as good as it's going to get. I can make it better, and so should you. More looks like square, but it's okay. There we go. With radius of 5, so that means from here to here is 5. Express the perimeter as a function of length. So this is what I want in the end. Perimeter of the rectangle is normally 2L plus 2W, but now I want this only with the variable L because it needs to be a function of length. So looking through this, I need to figure out a way to get a new value for W. Well, looking at it, I'm going to keep going here and show that this is 5 as well. I know a rectangle has right angles. This can be my length, this can be my width. What's jumping out at me right now is a nice Pythagorean theorem, this nice right triangle here. So I'm going to use that from my back pocket. Okay, it will be L squared plus the width squared is going to equal that hypotenuse, the side across from the 90, and that is 10 squared. I'm going to solve for W because that's what I want by itself, so I can plug into what I want. So I'm going to get 100 minus L squared, square root of both sides, so W is going to equal square root of 100 minus L squared. I'm going to take that, plug it in, and now I will have perimeter in terms of just the variable L. So go on here, perimeter would be 2L plus 2 times the square root of 100 minus T squared. Oop, not T, I'm sorry, L. That would be awkward. And I did what I wanted. I got the perimeter in terms of the length. Okay, so notice the pattern I do. I draw the picture, I figure out what I want to find, and then I do some kind of math work to replace. A couple more to get you in the feel. Number 3, let P of x be a point on the parabola y equals x squared minus 4x plus 9. Express the distance from P to the point 0, 6 as a function of one variable. Okay, let's be specific. It just wants one. So it doesn't even tell us what variable it has to be, but as long as it's made of one, I'm good to go. Now, for me, as always, let's draw my picture. This parabola would look something like this maybe. You know, it's positive, so it goes up. And I want to find the distance from 6, 0 to point P. And point P can be anywhere. I don't know, maybe let's put it here. This is point P, X, Y. I'm trying to find this distance, there to there. Okay, well, I don't know much. And again, I would be kind of lost if I didn't draw a picture. But I know distance formula is the nice square root formula. So if I want to find this distance, I can use this as my x1, y1, x2, y2, and see if that will give me anything. Right, that's distance formula. Those are 2 points. Let's see. So I'm going to do x minus 6 squared plus y minus 0 squared. When I FOIL, I guess, I could get x squared minus 12x plus 36, and this just becomes actually y squared. Like, okay, this is something. Now I'm going to have to use every part of the problem. So notice that I am given what y is. That's important. Okay, all information is going to be important, which means I could actually plug that in right here for my y value. I know the y value is going to have that equation with it because that's the parabola. Again, I'm just trying ideas. I tried distance formula, and now I'm looking at the problem and I'm going to use what it gives me. We have to make sure we square it though, so let's be careful. This stays the same. When I square, it's going to be x squared minus 4x plus 9. That quantity is being squared. And look at that. I don't have all x's now. That's exactly what I wanted. I wanted one variable. So I was able to do that. I'm going to keep going. X squared minus 12x plus 36. When I FOIL, I'm actually going to get, so I'm foiling that quadratic. So I'm going to get x to the 4th minus 4x cubed plus 9x squared. I'll get a minus 4x cubed plus 16x squared. This is a big one. Minus 36x plus 9x squared. Some of you are like losing your mind right now, but it's okay. Okay, doke. Man, oh man. A lot of stuff happening. That's all under a square root. I'm actually gonna make a nice big square root. But don't worry, this is not your answer. You have so many like terms that we can play around. Oh, golly. We have a lot of like terms that we can play around with. So let's combine our like terms together to get our distance in terms of just x. So let's see, I have an x to the 4th. Just one x to the 4th, so good. So I'm going to have a square root x to the 4th. Looking at my x cubes, I have -4, -4, so it's -8. Going to our x squareds, I have 1 plus 9 plus 16 plus 9. So it'd be plus 35. Combine your x's, I get -84x and plus 117. That would be your final answer. That is your distance in terms of one variable, x. I wrote the distance formula and used what it gave me. Example 4. A right triangle has one vertex on y equals 25 minus x squared, which is this red curve. It's actually a red circle if we zoom out. And one at the origin and one at x comma 0. Express the area of the triangle as a function of one variable. Again, it's not being specific, but you have to use one variable. Okay, so let's see what I know. 1 is at the origin, so this is the point 0, 0. This is the point x0. And then the other point is going to be actually on the circle right here. This is the point x, comma. The y value is given up here. The y value is 25 minus x squared. Depending on whatever that x value is, that's my corresponding y value. Okay, so what do I want? Area as a function of one variable. So I want area, which is normally base times height, or x times y, but now I want it in just one variable. This is what I want. Okay, well this is x, this is y. Let's see if I can play around. Well, I know x is x, that's fine. But we can rewrite y as that y coordinate. Based on whatever x is, the y is going to be 25 minus x squared. That's given to us from the problem here, so we can just plug it in, and it's also given when you graph the point. So now I can do a nice little distribute action, and I can find my area just in terms of one variable, just in terms of x. So you can leave it like this, 25x minus x squared all over 2, or you can simplify each term like so. It will not matter. Sorry, this should be x cubed. Doesn't matter how you write it. Okay, but you did what it wants. Area in terms of one variable. Okay, number 5. This is from page 251. A piece of wire x inches long is bent into a circle. Picture already shown. You're welcome. Express the area in terms of x. Okay, so my goal. Area equals, of a circle, pi r squared. But this time I don't want r. It says I want in terms of x. So somehow r needs to be exchanged with something in terms of x. Let's see what we're given. Oh, right here, circumference is x. That's important. Okay, so here in my mind, circumference is normally 2 pi r. But now it's telling me it's actually x. So look at that. I now have an equation with r and x. If I solve for r and replace it right here, I did what I wanted. So let me get r by itself, which just means I'm going to divide both sides by 2 pi. I'm going to plug that in here, And now I'll end up with area in terms of x. I'm going to simplify that a little bit. It's going to be x squared over 4. Notice the pi's will cancel. And you square both terms because it is in the squared term. Oh, I'm sorry. The pi's do not cancel out. Look at me as I just say it. Right? This would become pi squared on the bottom. So a pi and the pi squared will cancel. I'll show that. Sorry guys, I got very excited. So this really would be pi. It would be times x squared over 4 pi squared. Right? Everything gets squared. So this pi will cancel with one of the pi's on the bottom, but there will still be a pi in the numerator, in the denominator. Whew. You can tell I'm almost done. Last one. A right circular cylinder has a volume of 10 cubic centimeters. Find the surface area of S as a function of the radius of the base. Okay, here's my picture. Here's my nice cylinder. I'm not an artist, so do not judge me. My goal is to find surface area, which looking at the front page, it gives me my formula. Surface area is 2 pi r squared plus 2 pi r h. Okay, this is from the beginning. I want surface area, though, just with r. So that means h needs to be replaced. Well, let's see what we know. We know the volume is 10 centimeters cubed. Well, I can use that to my benefit. Okay, volume of a cylinder, again from the front page, is pi r squared h, which means that 10, that volume is pi r squared h. If I can get h by itself and replace it into my highlighted function, I'm good to go. Hey, not too bad. I can just divide both sides by pi r squared. H will now be replaced, and I will have surface area in terms of the variable r. Let's see what this looks like. So 2 pi r squared plus 2 pi r, instead of h, I'm going to put 10 over pi r squared. Notice some things are going to cancel, the pi and the pi, the r with one of the r's on the bottom. So 2 pi r squared, this will be plus 20 over r. And that's everything we need. We got surface area in terms of just the radius. Okay, just that r value. Okay, I know we're doing great. It's a lot, but this is going to be extremely, extremely helpful. So let's just do 2 more. I'm sorry. Okay. This one, no pictures needed. Example 7. 2 numbers sum to be 100. Express the product P in terms of a single number. Okay, well, sum means to add. So 2 numbers, x plus something, is going to equal 100. Now, some of you might want to put y, but then that's 2 variables. So if you actually think about it, x plus 100 minus x is going to equal 100, right? Depending on whatever x is. It's better to do this because you want it in terms of a single number, a single variable. Well, we want the product. We know product is multiplication. So just means multiply your 2 factors right there. You'll distribute. So it's going to be 100x minus x squared. Okay, so these are your 2 numbers that sum to 100. So then I take the product of those in terms of x. Okay, number 8, revenue is price per unit times number of units sold. You should know that. So here is price, here is number of units. price is often a function of the number of units produced. Normally you get P equals MX plus B. That's called the demand curve. Suppose the price, the demand curve, is actually P equals negative 0.5x plus 60. So instead of the general, it's now specific. Express the revenue as a function of X. Well, okay. Revenue is normally P times X, but now I only want it to be a function of X. Notice here, I give you what P is. Let's plug it in, and voila, you will have revenue with only the X variable being used. Make sure you distribute. R will equal negative 0.5x squared plus 60x. This is a lot, okay? Please, please, please rewatch this video, ask questions during class, but this will prep you for day 14 and as we move forward, as well as our packet of word problems. Get excited, guys. I'm proud of you. You can do this. Have some confidence.